My name is Mike Bauer. I'm the marketing manager over at Ranch Systems. And with us today, we're going to have Brian Ron and Seth Schweppes from CVC, Coastal Viticulture Consultants. Before I introduce Brian and Seth and let them get into their presentation, I'm going to just go over some housekeeping things for this this webinar, and I'm going to give a quick overview of the enabling technology, the telemetry that supports on-farm weather stations. So in terms of this webinar, given to the large number of attendees, everybody is in listen-only mode. That means you could hear us, but we can't hear you. However, we want to be as interactive as possible. So on your control bar, there's a question tab, and feel free to type in your questions at any point. I'll be looking at them, and I may interject them into the presentation. If not, we'll be addressing all the questions at the end of the presentation, where we'll have a Q&A session. We'll also be recording this webinar, and it'll be posted on our website in about a week or so. So I think that covers the housekeeping aspect, and let me just go into a little bit of a technology overview of the Ranch Systems monitoring and control technology. So we're a cloud-based remote monitoring and control solution, and what I put there is what we call our base station. It's configured as a weather station, and we talk to our server through the cellular network. So the data goes to and from the cellular network, and from the cellular network it goes through something called the APN server onto the internet, where it finds our online application in the cloud. Then you can access that application anytime, anywhere, from a computer browser on a tablet, or we have a mobile app as well, so smartphone, any type of smartphone. The other way that we can access our servers, not through the cellular network, but also through Wi-Fi. So if you've got a Wi-Fi signal within range of what we call the base station, then that'll work as well and save you the cellular charges. Important to note here, what I'm going to show you next is kind of our more typical type of installation, but we also do a lot of standalone installations. So in this case, if you've got just the weather station that you want to do, instead of our base station, we have something called a cell node. It's much less expensive, and it's intended for standalone applications where you're only doing a weather station or soil moisture monitoring, or some combination of applications on a single station. But typically, the base station, which acts as a gateway to our server in the cloud, we have nodes. These nodes communicate via local radio to the base station, which acts as sort of a hub. Now, we've just shown you a weather station. In this particular case, the node is doing valve control. It may be also monitoring pressure in the irrigation line. Here's another node that's connected to a wired soil moisture probe. We're working with AquaCheck on a wireless probe solution. It's going into initial field trials this season and should be widely available next year. So you see now we've got soil moisture, we've got valve control, we've got weather stations. We've just added a camera for crop monitoring onto one node, which shows that our hardware architecture is kind of modular. You could expand it, you could reconfigure it, so you always have your investment in hardware. If you have something that you want to monitor that's too far away from the base station, our range is with the 900 megahertz radios is about a mile. If you've got something that's like 2 miles away, you could hop your way back to the base station. So what we've got is a kind of a multi-hop star network. In this case, we're monitoring tank levels. And here's another node, and we're monitoring pond levels and controlling a diesel engine pump. We also control VFD pumps and standard electrical pumps. So that's a quick quick overview of the underlying enabling technology. Now, I'm going to, at this point, hand it over to Brian. Brian is a principal of Coastal Viticulture Consultants. CVC has been a reseller of ours for several years, and Brian has been around for a long time, has got a lot of experience under his belt. And also with Brian is his kind of right-hand man, Seth. And Seth will be talking about some of his use of our technology in the weather station applications as well. So Brian and Seth, thank you for joining us and preparing this presentation, and go ahead and take it away.
Okay, good morning, everyone. We are with CVC. We're certified professional soil scientists and agronomists. The presentation this morning will be focused on ranch systems technologies and the technologies that meld with that. I will show some slides or some data where we integrate other data that's collected on farm and integrated into graphics that are on the ranch systems website. I am trying to advance this slide. It doesn't appear to be allowing me to advance this.
Let's see. Click into the slide itself, and then.
I did.
Okay.
How about your arrow keys, Brian?
I'm on the arrow keys.
Okay.
Oh, I'm gonna get rid of the red dot and go back to my normal. There it was. Yeah, the red dot was what was preventing it. Okay, off we go. Good morning, everybody. All right. We're gonna focus on the weather data and ET measurements, but we're also gonna look at turning valves off and on, pumps and wind machines, monitoring and recording soil moisture, and monitoring and recording flow in pipes and systems, and those are the two key words here. You're going to monitor and record, so you can go back and look back in a database at what happened over time. We're not really going to touch on the cameras to monitor ranch access and those types of things, but those systems are there. We're going to discuss some of the alerts that are out there. And finally, all of the data and controlling the valves you can do via the web or via your mobile phones. And the data that's collected is in this database. which makes it searchable and graphable over several years, which allows you to go back and look at some of this data. And sometimes you don't know that recording this data is important until later in the season when you want to look back at something. So that's part of the power of the system. I'm going to start with irrigations. This is probably review for most of you here, but typically we begin our irrigations when crops reach a target threshold of water stress. You're going to use your pressure chamber, your parameters, your stress index, whatever. The plants are going to, or you're going to reach your trigger point and you're going to begin irrigating. Okay, the irrigation amounts that you're going to put on are going to be, you're going to calculate in one of two ways. There are probably other ways to do this, but it's usually a percentage of evapotranspiration, or you're going to look at your soil moisture and refill a portion of the root zone with a known or predicted amount of water. Now, for irrigation strategies, the reason I want to touch on this here is I'm both a consultant, but I'm also a grower. And one of the most powerful tools we have for quality is absolutely controlling irrigation. But as we control irrigation, it also impacts yields. So if we're maximizing fruit quality in vineyards, we do want to control the excessive vegetation, reduce the berry size, and increase the color and get the phenolic compounds going. But there are yield implications or impacts. If you have an orchard, and I'm hoping a few orchard folks are out there, where you're going to maximize fruit or nut crop yields and quality, you really don't want to have excessive growth in your orchards because you too much pruning, but you need to make sure you have enough water to size the crop. Now, my point here is that fruit quality should be appropriate for the buyer's intended purpose. If you're growing grapes for a high-end winery and they're paying you top dollar for your fruit, well, maximizing fruit quality and having the smallest, most intense berries makes some sense. But there are several tiers of wine, and so some growers need to maybe apply more water to make sure they get economic yields to stay in business. So maximum quality that results in very low yields may not be the most economically sustainable program for everyone, and that's so when we get talking about, I start talking about ET calculations, there's going to be a wide swing in there for RDI factors, which we'll get to. But that is part of your individual calculations that you'll have to determine based on your yields per acre and price per ton. Okay, we're going to spend water like money. You want to apply it efficiently, and you really need to evaluate the efficiency of your pumps and irrigation systems. If your pump's inefficient, you're going to be losing money there, and the irrigation efficiency is important in calculations. So we're only going to spend water where you're going to get an economic return for it. So what can on-farm weather stations, how can they help you with irrigation management? Well, you can measure soil moisture. You can turn your pumps and valves on. You can monitor and record flow rates and operation time. So you can verify that the pump actually did come on and the flow rate was sufficient and how long it ran. You can also monitor and record your pond and tank levels, whether it's a fertilizer tank or a water tank, and just to see how much water is left in the pond. Okay, so quickly we're going to go through a few slides here on where to measure soil moisture. Basically, it's by soil type. Hopefully, you're going to map your soils by available water holding capacity, because that is the primary driver for grapevine vigor capability, is available water holding capacity. If you group your irrigation sets or by available water holding capacity, you're going to be able to control your growth better and be more efficient with applying your water. Now, grapevine vigor is another way to help you place them, and aerial imagery is out there. I'm sure all of you are familiar with that. Here are some tools that you can use to locate where you're going to put your soil sensors. Web Soil Survey is one. There's the conventional soil mapping techniques, backhoe pits and all that. And there's soil resistivity, which we use a lot. I want to bring this up just to give a little plug for Web Soil Survey. For those of you who don't know what's out there, it is the largest database in the world. If you have a farm somewhere in the contiguous United States, your farm has been mapped and is on, and the Web Soil Survey map is there where you can bring it up. You can search their database and bring it up, but you can also bring it up on Google Earth. And as you click through there, there's a wealth of information for you to find. They also have a mobile app for Google Earth where you can put those maps on your smartphones. This is a resistivity map. The reason I'm showing this one map here is this is how we map soils with soil resistivity. You can see you've got three different soil types here. Let's see, I'll go to my spotlight. You've got this red soil here, a little spot here, and then this other soil area. So you may need more than one sensor to accurately measure the soil moisture across your vineyard or orchard. Okay, aerial imagery. This is you can see the bigger change here. I'm going to use my smaller cursor so my slides will move. But if this is a soil group versus this soil group, this can help you where you're going to place your soil moisture sensors. Okay, how much water are we going to apply? That you've reached once you've reached your trigger point or your threshold, then you're going to begin regular irrigations, typically weekly irrigations or several irrigations per week depending on your root zone and the porosity of your soil and those types of things. So how much water to apply can be either applying a percentage of ET or refilling a portion or all of the root zone. First, we'll take a look at ET, and I apologize for this. It's a little bit dry and probably a review for some of you, but this is I'll try to move quickly through this. Okay, ETO, which is the reference evapotranspiration. That's the amount of water used by well-watered lawn or well-watered grass. And the publicly available regional ET data that you get is usually collected in this manner. So that number, ETO, will tell you in your region how much water a well-watered lawn will use. Now, this term here, ETWS, I'm just using it for this presentation, just to separate the two. So for the nomenclature, it's the ET of the weather station. So this is the evapotranspiration measured with your on-farm local weather station, which typically isn't located in the middle of a big lawn. So that number, the ET weather station, ETWS, can be and most likely will be different than ETO. But both of them can be used to direct irrigations. Okay, the traditional water use requirement calculation is you take ETO times your KC, which gives you an ETC, which is 100% crop use, crop water use, which is how much the crops can use. Okay, the KC, the crop coefficient there, right here, is the percent shaded ground, or the average shade width near midday. Now your ETWS times that same percent shaded ground, or average width of shade, is your on-farm weather station ETC. Now again, this is 100% crop use, how much the crops can use based on your locally measured ET. The next step is you're going to take your ETC is reduced by a regulated deficit irrigation factor, an RDI factor. This is the amount of water the crops need to use, not how much they can use, to produce economic yields and acceptable quality. Now, an RDI percentage of full crop ETC for grapevines in California, at least with the clients that I work with, ranges 20% and sometimes 15% or lower, all the way up to 70 or 70% plus. And that has to do with the climate that they're in, the water demand, and also the tier of quality that their fruit's in. If it's a production vineyard and you're irrigating down near 20%, you will indeed improve that quality and make some things more intense. But it will lower your yields. And so the job of the vineyard manager in this instance is to find out where you should be in that 20 to 70% to maintain your soil moisture. Now, soil moisture, growth, yields, and get the fruit right. Again, we're trying to grow fruit that's acceptable for the intended use. Okay, soil moisture readings and plant stress measurements can help you fine-tune the RDI factor. 20 to 70% is a huge swing. Where do I fit in on that? Well, we're going to talk a little bit about that. The final adjustment in calculating water applications is irrigation system efficiency. Simply, it's the ETC, whether you're getting it from regional ETO or on-farm local ETWS, times the percent RDI times the percent point whatever irrigation system efficiency. That's the amount of water to apply. Now, I will give a plug here to Dr. Larry Williams, Vineyards, and Dr. Dave Goldhammer in Orchards. They both have published a lot of research regarding KC factors, RDI trials, how to use ET to schedule irrigations. There's a wealth of information out there. Google them, Bing them, or whatever search engine you use. There's a lot of information for you guys to dig into this, and there just isn't time to spend enough time on this subject alone this morning. Okay. On-farm weather ETC, or even the ETO, can be calibrated using surface renewal technology. This is a new technology that's out there, and I just wanted to briefly mention it. It is a way to directly measure water use in a vineyard or an orchard, and it will give you a direct measure of ET by the way eddies or wind moves through the vineyard or orchard. It's an interesting technology, and you can use it to calibrate your ETCs, and you can also use it to extrapolate your data from different ETCs across your property. Okay, calculated amounts of irrigations can be fine-tuned with soil moisture. We'll look at that once you have a feel. So if you look at this, and if let's say you just want to go in, I want to go in and I want to refill my soil moisture. This is what I want to do. Why do I worry about ETC or ET or ETC? Well, this is, once you have a feel or a fudge factor or a correction or a delta between ETO or ETC and what your crop is using, you can use ET forecast to calculate the upcoming week's anticipated water applications. Now, if you're running a smaller operation, maybe you're a little more nimble and you can go and change things during the week, but some of the larger operations really have to use their personnel and schedule their personnel on a weekly basis. And getting a feel for how ETC, your calculated or measured ETC, and the ET forecast work together, it will help you anticipate what you should be doing in the upcoming week. And once you kind of get this, the ET forecast anticipated water applications, it's going to be 20% higher or 30% lower, you can make those adjustments, and then you can extrapolate those in areas that have similar blocks, similar variety, rootstocks, and soils. You can take where you're measuring and extrapolate it across larger areas. Okay, there are several different soil moisture measuring devices out there. I'm going to talk about capacitance probes. There's, the gypsum block stuff. There's a number of things out there, but just for the sake of a very short presentation, I'll mention these two. A capacitance probe typically is these two. There's a sensor here, and a current goes across. I don't know if you can see my cursor or not, and this will go a couple inches off of the tube, and you see there's several sensors here as you go down in depth. This is an AquaCheck, and it's a little different. It's sealed into a resin, so the sensors are sealed, and you can't adjust them, you can't move them, but they also don't leak. At least I haven't seen one leak yet. Okay, this is soil moisture data collected from a capacitance probe. And what we've done here is, this is more or less our sweet spot, the blue area right here. Let me switch over to my spotlight. The blue area here, this is where we think we're getting maybe a little too dry. This line here, you can see this is a graph that we've taken off of the Ranch Systems website for data that we had on a particular ranch. It starts in July and ends in October. Well, this blue line here was much higher earlier in the season. And what this blue line represents is a totalizing graph. It is the sum total of the available water in what we call our critical root zone. You can see this is the soil moisture has dropped off, has continued to drop. This graph here, where we've taken outside information and plugged it into the Ranch Systems graph, is what we call stress index, and I'll have a slide to show, just a quick slide to show you what that is if you want to look at it later. When a stress index is 0, they're under no water stress. There's no reason to irrigate. As the stress starts to increase, then you're getting to the point where you may start irrigating. You can see there was a small irrigation applied here. The water continued to drop and got down maybe a little bit drier than what we deemed to be optimal. The stress index jumped up here to a stress index of 2, and once we get to a stress index of 2 and 3, well, then regular irrigations are going to begin. Now, here's where you can use your ET calculations to determine how much water I want to apply every week, and then see where your results are, whether you're staying in that sweet spot, or whether you're driving the moisture too high, or whether the moisture is continuing to fall, and you don't have your ET calculations quite dialed in yet. The other way to do it is to apply some water and then try to figure out how much water it takes to fill this up to this level, and then let it cascade back down and then refill it. Now, you can see here that there was more water being applied in this area here, and then the stress level continued to rise. So they did a pretty good job with this increasing stress of increasing the soil moisture to keep the stress from going too high. Here you can see that this was a post-harvest irrigation, and it drove the water level much higher, more like it was earlier in the season because we'd finished picking the crop. Okay, this is stress index based on tip observations. This is 2 and 3. Typically, your 14s and 13s, 14s, 15s, 16s of pressure bomb. This is more 15s, 16s. This has you look at the tips and also canopy temperatures, but you can take a look at that later. You can use your on-farm weather stations to reduce common irrigation inefficiencies. The one irrigation set across variable soil conditions, that was that soil mapping thing I showed you earlier. We'll just focus on looking at avoiding pushing water below the root zone in rocky or shallow-rooted grapevines. If you've got a big, deep soil, chances are if you're applying weekly irrigations, you're not pushing water past the root zone. But there are instances in what we call skeletal soils, rocky soils, or shallow-rooted, where there's shallow-rooted grapevines, where you can do that. Okay, how deep are the root zones in each soil type? I'm kind of getting back that whole soil type thing, that available water holding capacity map, because that's a real key towards applying water, just enough water in a same soil unit without running too much water in another, or applying water or not enough in yet a third area. So you can take a look at your root systems here. You can visually take a look at those, dig down there and look. But also soil moisture measurements can reveal rooting depth. And there's many types of sensors that will measure soil moisture. You really should know the limitations of the technology to properly install them and interpret the data. But so we're going to look at some more data. This is more capacitance probe data. You can see there are several depths as you move down this graph. I'll put my pointer back on here. as you move down this graph. This was more or less a relatively full point. This is empty, and this is the surface. And as you move down in depth, you can see these generally begin to slide down until decreasing in moisture, until if we were to place our pressure bomb data or our stress index data or what have you on this same graph, you would see that that data came up high enough to warrant regular irrigations. Now you can see each irrigation event, it shows you how full you got each profile, each area in the or layer or what have you in the soil, and about how far the water went. Here we got quite a bit of water moving about 24 inches in depth. We got a little bump down here about 32 inches and not much more down here. You can see that this black line continued to slide. Now what's interesting about the capacitance probes is you can watch the diurnal use of water. In other words, you've got the water drop here during the day, and then that little flat plateau at night. So this will show you how deep your water went. Okay, let me get rid of my cursor, and I'll be moving on to the next slide. Now this is another way to look at the data that can show how deep the irrigation actually went. You've got water applied here, and you can see a heavy bump all the way down to the lowest strata, which means if your primary root zone was up in this area, say, and you see your water, the soil moisture increasing below that, you're pushing water below your root zone and you're unable to use it. In this case, you would split up your applications to verify that the water is only going as deep as you need it to go. Okay, at this point, I'm going to turn it over to Seth Schwebs, and he's going to talk about some distribution uniformity problems, and then get into the heat stress monitoring and some of the other uses or applications of on-farm weather systems. I'm switching now.
Okay. I think you can all see mine. I left off the last slide there. So on-farm weather stations and the common irrigation efficiencies. So Brian went through what can happen when the irrigation sets traverse across different soil types, and in particular soils with different water holding capacities. And so then in the case of a vineyard, you'd have to decide whether you're going to put in a second drip line or irrigate to the wet and over-irrigate irrigate to the weak vines and over-irrigate the rest of the vineyard, or vice versa. And then the second point, pushing irrigation below the root zone, particularly in a water-challenged year like this one. That can be a real problem. Now, there may be instances in maybe the Central Valley where, in fact, we do want to push some water past the root zone, in which case monitoring the water movement through the soil with a tool like the AquaCheck is really fantastic. Some of the other tools where you're only monitoring irrigation maybe once a week or something like that, you may miss how deep that water moves through or past the root zone. So knowing how far down your active root zone is, and then being able to monitor your irrigation, make sure it's filling up that area, but that you're not wasting water pushing below it's important. And then other issues here, the distribution uniformity. There's some fantastic resources online where you can go out to your irrigation system with a graduated cylinder and a stopwatch and get a sense of how that's working for you. But also the ranch system stuff will, if you have a irrigation system set up with ranch systems where we're turning valves on and off and monitoring pressures and flows. You can do some math with that information to make sure that the water you think you're putting out is indeed the water that's going out. So that's the wrong way, I believe. Let's see. I'm going. This going the wrong way. Sorry, I don't spend a lot of time with PowerPoint here. Okay, this is the next one, right, Brian?
Yeah, can you hear me?
Yeah. Okay.
Okay, well, no. Keep going.
Okay, here's what I wanted to get to.
Yes, now there you go.
Okay. All right, so this is an example of a vineyard where we have ranch systems turning irrigation valves on and off. So here you can see we have 9 blocks, and then this was a weekly irrigation from last summer, early on last summer. And so here you can see we turn the valves on, and we have the time they start and then the run time. So you can see here we have some short irrigations. I believe these were the grower testing the system, and then some longer irrigations here. Block 1, I believe, is a different varietal than the rest of the vineyard. You can see it's getting somewhat more water there. But this is great. The advantage of being able to schedule irrigations like this is they can run at night. So there may be some efficiencies there with your power company. I believe PG&E is still, your off-peak hours at night, running your pumps. There may be also an efficiency with your water, less evaporation happening during the cool hours at night than during the day. But the other big advantage of this is, like Brian alluded to earlier, is that this information all goes into a database that come January, when you're reviewing your last year's season, and you're sitting down with maybe a crop consultant, the winery you sold your grapes to, whoever, and it's surprising how sometimes people don't have the best records on their irrigations, but this way, this is all being kept track for you, and there's no guesswork about it. You know exactly when it was run and when, and it can be a really valuable resource. Whenever we're set up a system like this where we're turning valves on and off automatically, remotely like this, it's important to have a feedback loop. So in this case here, this is a flow meter that was installed right next to the well. So this vineyard's watered off of a well. When the pump turns on, all that water that the pump's sending out is recorded with the flow meters. So this lets us look at a few different things. This is when this particular valve was turned on. Here's where it was turned off. We can see this peak here that correlates with that block running. These other spikes we're seeing here were other blocks that were running previous to this one. And then this is some domestic use off that well, filling up a tank, some landscaping, and you also might see something like this when you're filling up spray tanks or washing down tractors after a spray. But besides just verifying that water is going out, with the flow and knowing how many vines you have in your block, what your emitter size is, those types of things, you should be able to get a pretty good ballpark of what's going on with the flow when a particular valve is being turned on. And then you can double check that by running it and watching and seeing where these peaks are. And then with the ranch systems alert capabilities, which is, commonly we focus on frost alerts, but those alerts can be set for any sensor that you have coming into the system. So in this case, if we were to see something, say, a flow of over 5,000 gallons per hour, we would set an alarm that that would notify everyone that flow is being exceeded, and that would likely indicate that either you have too many blocks running at one time, which may mean that you're not having sufficient pressure up to each one of the blocks, or there is something in the irrigation line has been compromised, like a broken pipe or something like that. This particular case, we're not controlling the pump per se. I believe this is a VFD that runs this particular one, but we're not hooked up to that. But it would be advisable to have something hooked up where then you could shut that pump off should that flow get exceeded. But also you want to make sure, going back to the previous slide talking about clogged emitters and things like that, that the flow that you're anticipating, we're matching that. So if this is right about where we expect this peak to be, if we were seeing this peak end up somewhere down here, we would know that we'd have plugged emitters, or maybe the second irrigation line that we had intended to have turned on wasn't turned on, or something like that. So this is a lot of great information. The feedback loop, not only for the safety of the irrigation system, but also being able to turn those valves on at midnight with nobody on the ranch, have confidence that you're not wasting a bunch of water, and what's happening is what you expect to be happening. So here's a case of a frost alarm. I like to show this example because you can see here we had a frost event May 22nd. So this really shows the value of having these sentinels out in your vineyard, because this was well outside of our anticipated frost season. And in fact, in this particular case, I got a call from the grower saying that the temperature sensor was broken, and I needed to come out and take a look at it. And, why was it broken? Well, the alert went off, and did you go look at the vineyard? And sure enough, about a half hour later, I got a call. A very unhappy grower that indeed the station was working correctly, and they suffered some frost damage. So having these alarms set and kind of forgetting about them, but knowing that they're there can be really valuable in outlier situations like this. So here's that frost alarm set up in this particular, in this example, but also setting heat alarms is another great use for these systems, and can be, even with a relatively basic setup, weather station setup, we can use these alarms in creative ways. So in this particular case, I just pulled up the OSHA heat stress. So this alarm may go out to vineyard foremen to make sure that the crews have plenty of cold water, shade structures are in place, and should things get really hot, maybe that's a day the crew goes home early. The heat events, also if the vineyard is capable of some sort of overhead cooling or misting or something like that, the alarm could be used to trigger that. I like these examples because I think that with the ranch systems, even a basic weather station where it's just logging temperature, humidity, rainfall, wind speed, wind direction, there's a lot of data there that we can use, and the more we can leverage these stations to do some of these different things besides just sort of what you would think of with a traditional weather station, you really leverage your investment into these stations. So these are just a couple examples, and then this slide, I wanted to focus not only on the disease modeling that Ranch Systems is capable of doing, and again, this is just a basic weather station showing the mildew index we're all familiar with in vineyards. But in this case, we added in some additional data, much like we added in the stress index that we showed earlier in relation with the soil moisture. This shows a powdered mildew spore count, which is something we've been working with to get a better idea of what's going on with powdered mildew out in the vineyard. So this isn't values that the ranch system is recording per se with a weather station, but this is just a piece of data that with very simple setup, you can add in these custom parameters into the ranch systems website and then take a look at this data alongside the data that's being recorded by the weather station to really get a good idea of what's going on. So here's the 0 to 100 scale. So this is high mildew here. This would be moderate here. But you can see our spore count. This is actual powdery mildew spores floating around in the vineyard. We had a couple blips here, but then mildew really came on here in somewhat correlation with this peak here. Although typically we expect to see this shifted back a little bit, but nonetheless, a great example of leveraging, in this case, the ranch system software to really paint a great picture of what's going on with the vineyard. And this is what our spore trap looks like. So this is a completely analog. This has some sample rods here that we send in. We do a quantitative PCR test to detect powdery mildew. Great tool. And then this is the chart that we would typically put out. And this is Ranch Systems data. So this is an example of integrating the Ranch Systems data with other types of tools that you're using. So this is just the high temperature, this blue line, the high temperature off the Ranch Systems, and calculate mildew index, and then our custom data here, which is the result of our powdered mildew assays, and in this case too, we put in the growers' sprays.
Hey, Seth.
Yeah.
This is incredible data. How do you apply this in farming practice?
Okay, so so here, starting out in the beginning of the season, you can see we put in an oil. Then we could see that the mildew pressure was high, and so that would typically indicate that we would stick tight onto our on our intervals. But in this case, we actually pushed our intervals based, and we got a low-level reading here. So although the calculated mildew index was saying it was high and we should keep tight intervals, we actually pushed this oil interval a fair amount until we got a low-level reading, and then we waited longer. And here, roughly May 20th to June 10th, I think that's stretching the interval a little bit, but we got another positive here, which, even though the mildew pressure was low and would indicate that we could push our intervals, we got a significant hit with mildew here, so we got out and did another spray. Now here, I believe we have an example of a wider spread where it's almost a month in between sprays, and of course this varies depending on where you're located, trellis type, vigor of the vines, all kinds of things. But this is a hillside Cabernet vineyard, and even though our mildew pressure was quite high, indicating that we would want to shorten our sprays, we actually extended it slightly because we had some low-level readings and were clean until it popped up again.
Yeah, and Seth, if I may here,
Mm-hmm.
Absolutely, yeah, those are 21 to 28-day materials, and pushing it out to a month or maybe a little more than a month on a 21-day or 28-day material under high mildew pressure isn't what we're always recommending to do, but using this data, it allowed us to do it. And yes, under high mildew pressure, pushing your applications that far can be risky, but with this data, it allowed us to do that.
Yeah, yeah. It's 2013. We actually, and this was a more sprays than we put out the previous 2 years using the same sort of setup. So, but again, the integration of data, the local weather and local mildew index that we're calculating with the ranch systems, rather than relying on a CIMA station or something else that may not really represent what's going on in our vineyard. So, and then of course the also in relation to mildew would be looking at the wind speed sensor to figure out where your windows to spray are. So we set the cutoff here at 10 miles an hour, and you can see we have these gaps here that we can, if we can detect a pattern, which is pretty apparent here. We can use that for timing our sprays. But then also, if the vineyard's remote vineyard, difficult to get to, allowing the operators to get in to check this data to make sure that before they drive out to the vineyard and to get started, that indeed it is an appropriate time to get it going, and there's not something happening where the window might be shut due to current weather patterns, and you may have to wait a day or two in order for the winds to calm down and get that spray put out. So this could be a real time saver for the guys to rather than having to drive out to the vineyard to see if it's too windy to spray. And I think that gives us a little bit of time here left for some questions, Mike.
Yes. So everybody, any questions that you have for Brian and Seth, just type them in to the question window, and we'll answer them as they come in.
Also, while we're waiting for questions, I do want to mention there are other soil technologies. Can you use a neutron probe to figure out if you're pushing water past the root zone? Absolutely yes. Can you use other type of soil sensors to do that type of thing? Absolutely yes. Can you identify your root zone depth using other types of soil measuring equipment, neutron probes, etc.? Absolutely yes. These are the examples that we've chosen for this presentation because we had some nice data to present, but I just wanted to be clear on that.
Let's see. I saw somebody had their hand raised for a question. We could do it that way. I accidentally erased that hand. So the other way you could do it is you have a button that raises your hand, and I could just unmute you, and you could ask your question verbally. Let's see. Okay, here's a question. How deep are you monitoring?
Okay, I'll take this. Oh, okay. How deep are we monitoring? The probe data that we showed there was 48 inches. There are 60-inch probes for the AquaChecks. The Centec stuff can be deeper, and that is a good question and a limitation of the capacitance probes. If you feel you've got a 6 or 7 foot root zone, then the capacitance probes may not be the best technology to measure your entire root zone. But the data we presented was 48 inches, and there's a 60-inch model as well, 5 feet.
Okay, other questions? I'm not seeing any coming in at this point, so we'll just wait for another minute or two. If anybody comes in with a question, and meanwhile, while we're kind of waiting here. Brian and Seth, I want to thank you for, again, for putting together this presentation and sharing it with our audience. So a question has come in. Can you use a sensor to monitor fertilizer in infiltration depths?
Okay. Now, I'd have to.
Wait, let me reread this. I didn't think I. Can you use a sensor to monitor fertilizer infiltration depths? There we go.
If you're talking about a fertigation, if you were going to apply a fertigation, then yes, you can. Yeah, you could see just how far on that example we had there. Seth, I don't know if you want to kick it back to me so we could back up a little bit.
Let me get that.
Or just back up the slides, whatever you want to do, that's fine.
And there's an addition to that question that says, can you also monitor the salts building up?
Next one. Next one.
This one?
Yes. Okay, and you're gonna have, okay, you're in control. You can just circle that area there. You can see how deep if you fertigated during that first event there, just to your left a little bit, Seth.
I am switching it over to you. There you go.
Okay. Bear with me. Up we go. Okay. If you applied your fertilizer here, you could see that you move material down at least 24 inches, and again down to about 32 inches. If this were a fertilizer application here, you only move you move the fertilizer down about 16 inches, with a tiny blip here, perhaps a little bit at 24 inches. So yes, you can use that logging technology to give you a better idea of just how far that onion of water moved. And there's a second part to the question, Mike?
Yes. So can you also monitor the salts building up?
Well, let's go to the next slide. Okay, if you were going to continue to irrigate in this pattern here, where this deep profile here, the deepest sensor, say it's 4 feet, 5 feet, or you're using a neutron probe and it's 6 or 7 feet, however deep you're looking, if that flat line's on the bottom and you don't get water moving down through here, like this slide shows, you are absolutely accumulating salts. And if you're trying to push water past the root zone, and that is a great question, the idea of not pushing water beyond our root zone is a great idea unless you need to leach salts. In that case, you want to make sure that however deep your root zone is, that you're getting water moving at least that deep or beyond it. I hope that answers it.
Yeah. So I've got a question, and this that I've always wanted to understand better is with the Centec probes, they could measure EC. Have you got experience with that, and how do you use that data?
Well, you can. The issue is, though, is that the salinity usually builds up the highest on the edge of that wetted onion, and those probes don't measure a few inches off the tube, so they're not really in the highest salinity area. But yeah, that data can be used too. Absolutely.
Yeah. What I'm hearing is that's not the best tool to use to get a sense of what's going on in the salt levels in your soil.
Yeah, I would probably collect soil samples near the wetted edge of where you anticipate that onion to be, because that's going to be the highest salt concentrations. And then if you were going to apply a flushing application of water to move the salts out of the root zone, I'd want to verify through whatever method I was using that I had driven water as deep as the root zone and beyond it.
Okay, great. Any other questions from people? Either type them in or raise your hand, and we'll address them. Okay, another question has come in. Does Ranch Systems allow for external data to be uploaded and analyzed through their platform? So the answer to that is yes. The Ranch Systems architecture is an open architecture. It's designed so it could interface with virtually any sensor and bring in other data that could be analyzed. Also, we're very open, so we do a lot of uploading of data into other applications, most notably farm management applications, like OnFarm is our latest software partner, where the data gets sent and viewed into their application, where they're aggregating all data related to the farming operation. Regarding the external data coming into Ranch Systems, what we've been doing a lot of lately, and we often do this to meet specific customer requirements. We're integrating a lot of third-party weather data, particularly forecast data. So we're working with bringing in Western weather data and CINMAS data, sometimes into our system, those types of things. So hopefully that's given at least a partial answer to the question. Okay, anybody else out there? Just looking. Okay. Well, I think that's all I'm seeing right now. Well, you can see Coastal Vit's contact information, their phone number, and Brian and Seth, do you want to give your emails to people if they want to send you an email with any follow-on requests or questions?
Sure, absolutely. Go ahead, Seth.
Sure. Mine is SCHWEBS@coastalvit.com. And also just another shameless plug, if you have the current Practical Winery and Vineyard, there's an article in there talking that I wrote with Doug Gubler and Walt Mahaffey about the spore traps.
My email, which probably should have been on this slide, is brahn, there, BRAHN, @coastalvit.com.
Okay, so it's just first name initial, last name spelled out.
Uh-huh.
Okay, once again, Brian and Seth, great presentation. Thank you very much. And everybody out there, thanks for joining us. We're going to be doing another webinar in the middle of May, and that'll be specifically on how our system works with farm management applications, and we'll be showing the integration of our system with OnFarm. Okay, thanks everybody for joining us.